And this is part 2 of the Fender 5F1 amplifier that came in for repair a few days ago. I showed this thing to you guys, had some wiring issues. It's got that giant 500 ohm resistor and it doesn't work. I kinda got it to work, so I know it's savable. So what I'm going to do in this video is gut it out and rebuild it from the ground up. Here we go. Alright, so here she is. Now we tested this in the last video and got it to operate, but it was weak. So instead of trying to repair this wiring and repair the jumpers that are missing under the board and clean things up, I'm just going to get it all out and we'll start from scratch just like I was building the amp. Alright, so I give you a close-up of the things that need attention. For example, the wiring on the 12AX7 socket. You come over here, you can see a terminal board with a wire that's just kind of poking through. I don't know if that was part of the kit. Down here we need some attention by the filter caps, and of course all the extra wiring. I plan to tidy that up, make her nice and neat looking. So that's what we got ahead of us. Like I say, the best way to approach it is just take it all out and do it again. Just going to unsolder all the wires. I really don't care where they're going, because all this will be new when I'm done. I also plan to do a little bit of color coding so that when you look in here you can say, hey, those red wires must mean high voltage, those black wires must mean ground, and maybe blue wires would be the cathodes. I'm not sure yet. But I just gotta get this all out of here, clean up these tube sockets, and go from there. Pretty well have it gutted out now. So next step, I'm going to remove all these wires. We're going to go underneath and get all the jumpers where they need to be, and I'm going to attach some color-coded wires to make reconnection easier. I thought before I start this project I should review the wiring diagram on MojoTone's website to make sure it's accurate, and it pretty much is. We know that in the past we had 2 amps that were missing this wire right here, which goes underneath. That supplies voltage off the 22K resistor over to the 200Ks, which provide plate voltage to the 12AX7. Okay, so that's been repaired once again in this amp. Now also, we noted that we had a problem with grounding in this amp. Remember, the first 2 caps are grounded, but over here I didn't have any grounding going to the cathode of the 6V6 or this filter cap. Well, if you look, this is also kind of confusing. There's another jumper that goes underneath over here to the 1.5K resistor. And then there's a green wire that goes up here to the volume control, which is the low side of the volume control. So you'd think yeah, this needs to be grounded, right? Well, it actually is. If you go all the way over here, if you follow this green wire up, it's grounding through the audio jack. So that is providing the preamp ground, and this cap not to the same ground as these power supply caps. The power supply caps take off over here and go to your ground lug on this terminal strip. So you may think, well, maybe I'll just put a jumper here and not use this ground path. Well, I experimented with that to see what would happen, and it causes a lot of AC low level hum. So follow this diagram. This is correct, but make sure if you're using the ground on this audio jack that you use a star washer, because if you have a bad ground, you're going to have hum. Alright, the other thing I really don't like about the 5F1 design is the puny little filter caps. We got 16, 8, and 8. Okay, these are severely underrated for what this amp has to deliver. You need more capacitance, otherwise you will have some low level hum. So I'm going to bump them all up. This one will be a 33, this will be a 22, and this would be a 10, all at 450 volts. Alright, so here's a little update for you. I've got the board pretty much rewired. I've color coded all the leads. So now we have blue for the cathode leads, white is signal, this is going to the 12AX7, and here's our 2 high voltage lines. This yellow one goes under the board up, and that's going to go to the volume control. That red one is my screen, this white one is a signal that's going to feed the 6V6. Inside, I've kind of rearranged the filament wiring, and you can see I've got my high voltage lead here. So my balancing resistors now, the 100 ohm resistors going for the filaments, is down on this little terminal board rather than on the back of the light. I don't like this. To me, it's a hazard waiting to happen, so I'm going to remove those resistors, and they're down here, and they'll serve the same purpose. So one thing I really never liked about these new 5F1 kits is how they mounted the eyelet board. They would put an insulated board and just put screws through it, lay this other board on top of it, and screw them together. I always thought that was kind of hokey. So what I like to do is put little standoffs in here that you can see, and that's using the existing screws, okay? Then I put some little rubber bumpers over here to support the back of the board. So now, you just take the board, slide him in there, get him to pop over the screws. Of course, it's kind of difficult for me to do this and have the camera in my hand at the same time. But anyway, you get the idea. The screws pop through, you put some nuts on there, a little drop of adhesive, and then it has a nice solid platform, and it's spaced above the chassis. So I've had some of you write in the past and say, you know, I have a tough time getting the spacing correct when I'm wiring these jacks, and I got to fight with them to get them to seat into the panel. Well, here's the trick, guys. Take your amp, mount your jacks on the outside in the same configuration as that diagram, okay? You wire them up out here, and when you're done, just unscrew them and flip them around, and guess what? They'll fit perfect. Alright, you'll find that your audio input jacks that come with this kit do not have lock washers. I would highly recommend that you install some before you mount those jacks. If you don't want to fight with these things coming loose and having hum and buzz in your amp, invest in some of these lock washers. So I'm about ready to wire the board in to all the jacks and controls, okay? There's one thing I'd like to discuss about these amps, and this is no fault of the design, it's the fault of these new components that we have out these days, okay? So take a look at the volume pot. The volume pot has a switch right on the back of it. Well, guess what's on that switch? 120 volts AC that is switching across the contacts, and that turns on your amp, right? And then here about 1/4 inch away from it is a carbon pad of your volume control that has a preamp level signal on it. Guess what can happen? The AC can actually induce into this pod and give you hum in your audio, and you'll be like, where is that 60 hertz sound coming from? Well, see, they got away with it back in the good old days, because back then, well, that's nice, got my wire in there. Back then, the backs of these pots were sealed. The metal went all the way across, okay? So they were able to stack switches behind it, and it didn't get into the audio. These new pots are not that way. These backs are open, and there's little pop rivets here that simply pop rivet this switch onto the back of that assembly. I have had problems with this in the past, so I do have a suggestion. And yes, it's not going to be original, but what you can do is you can relocate your fuse holder to the back of the amp, okay? So it would be down here. And in the place of that fuse holder, you install a bat handle toggle switch with a 1/2 inch mounting shaft, and that takes the AC off of your volume pod. Back to the diagram for a quick little safety tip. Here's your AC line coming in. Obviously you have a ground, you got a neutral, and you got your hot, right? Follow the hot up to the fuse holder. You see where the hot lead's going? And then the center lead here goes to the transformer. It's actually backwards, okay? The hot line should be on the center post of the fuse, and then the side tab should go down to the transformer. Let me go out back to the amp and I'll show you why that is. Alright, so here is the fuse holder, okay? And here is what I'm talking about with the terminals. This is the side terminal, and that goes to the ring. There's a ring in this fuse holder that the cap clips to. Then you've got the center post, okay? The center post is spring loaded and it keeps tension on the fuse, alright? So let's say that you blew a fuse. And you say, oh, I'm going to pull out my fuse and replace it, right? Well, if it's on the center ring here, look what can happen when you pull the fuse out. I'm still touching the center ring. My finger can touch this, and if the fuse is still good at this point, it's going to shock me, okay? So it's just a good practice to connect these up correctly. Obviously, if you're going to change your fuse, unplug your amp. But if not, that's why they did it this way, okay? Well, here's the 12AX7 tube all wired up with the new color-coded wires, rather than just a whole bunch of yellow wires and you have no idea where they go, right? This really simplifies it. My reds are my high voltage, my blues are my cathode, white is signal in, this yellow comes out the volume pot, and of course the green is the filament. So you can kind of look at that and know where everything goes. It saves you a lot of time and hassle, especially during troubleshooting. So that brings up another subject that we need to discuss real quick, is the cathode resistor. Normally there was a 470 ohm resistor that would sit here next to this 25 microfarad cap, and that would go to pin 8 of the output tube. Okay, now that 470 ohm resistor, guys, was used back in the day. It may not necessarily be the right value. I'm not going to tell you to go with it or not. What I'm going to tell you though is you can check those values on the Weber bias calculator site. So you check your high voltage, in this case it's around 400 volts, and you want to check the current through the 6V6 in Class A operation. And there's a chart there that tells you what current levels give you what percentage of wattage. I choose the 1K for testing, and if it falls in with the current rating that I'm after, I leave it. So that's why I'm going with a 1K. So to ensure that you set your bias correctly on your 6V6 tube in your Fender Champ, I'd highly recommend that you go to the Weber bias calculator website, and that's what I'm showing you right here. There's another little trick that you can do if you'd like. This cap here, the 25 microfarad cathode cap going to the 6V6, is in there to give you a certain amount of bass response. If you want a little bit fuller sound, I recommend bumping this up to a 100 microfarad cap at about 50 volts. Alright, so let's talk about the rectifier tube in the power supply section on the 5F1. Now the 5Y3 is the stock tube that this amp has run forever. Some of you out there have wrote in and said, man, I'd like to put a GZ34 in there, get a little more output. Or perhaps I would like to put in diodes instead of the tube. My recommendation is, guys, don't do it, okay? If you do that, you are going to lose the natural voltage sag that this tube provides and the current limiting that it provides as this amp is warming up. You put in diodes and you're going to shock this thing with about 500 volts. As soon as you flip on that switch, you're going to damage your amp. I do not recommend putting diodes or any other rectifier tube in this amp besides the 5Y3. Alright, so what I'm going to do before I power it up, we're going to buzz it out real quick with an ohm meter and make sure that it's safe to operate. So I'm at 200 ohm position. Meter's working. Pretty much what you want to do is make sure, number one, that your grounds are there. So all these caps, as we discussed earlier, should go to chassis ground. Okay? So should the cathode resistor over here, the 1.5K, right? And the junction here of all these resistors and the cap, and eventually this guy here. Yes, so all that's good. Now we know we have a good ground, so what you don't want is a short in your amp. So now I'm just going to go to these filter caps and make sure that we don't have any continuity from any of those to ground, because if you do, short circuit time, right, you're going to damage your amp. So that's the quick checks to make sure that it appears to be safe to turn on. I would also check your line cord to ground, right? Make sure that that's not shorted. And of course you can go through and buzz out the other windings, your filaments, things of that sort if you wish. However, the main things to check are the grounds and the high voltage caps for shorts. Alright, so this is initial power up of the 5F1. I've got a meter, we're going to monitor the high voltage, and have another meter over here, we're going to monitor the current through the 6V6 tube. Now normally I would do this using a Variac, but I know that most of you do not have a Variac available. So we're just gonna power it up and see what happens. So I have the switch on, the volume's all the way down. I'm gonna plug it in. If we see anything go wrong, I'm gonna unplug it. But remember, I can't move faster than the speed of light, so if something's wrong, we may see some smoke. Here we go. Boom, she's powered up. There's a high voltage. So you go to about 440. It'll start nosediving as we see the current coming up over here. And there's the current to the 6V6 through the 1K resistor. The high voltage is settled down to about 400 volts. I've got about 31.5 mils through the tube. No smoke, no arky sparkies, we're good to go. So I'm going to unplug it, solder that resistor in, get the meters out of here, and we're going to put on a scope. Here's the oscope check. I've got my leader audio generator going into the input of the amp. We've got a D-Lab demi-load resistor simulating the speaker, and I've got the scope sitting here. Okay, so let's bring it up. I see a sine wave. Let me cut over there. There's the output. I can vary the frequency here. Looks nice and clean. The next test I like to do on these amps to ensure that they're going to be quiet for the owner is a noise floor test. So we're still connected with the scope across the demi-load, but now I have nothing on the inputs. Okay, so I just bring up the volume and look at the noise on the scope. So here we go, bring it up. I'm at 0.1 millivolts per division. That's full volume. So this thing's going to be as quiet as can be. And this is also a good way to figure out if you have a feedback issue. Because if you crank it up and you start getting a squeal, you'll see that on the scope. This gives you a good opportunity to catch that before you turn it over to the owner and says, man, this thing sounds terrible. Alright, so she's really looking good. I've got the pilot light installed and it's wired up. The other thing is I wanted to tell you guys about, if you would like a little bit more of a MIDI sound to your champ, what you can do is pretty simple. You go right here, you see your 1.5K resistor, go into the cathode of the 12AX7, strap a 22 microfarad 50 volt cap, positive over here, negative to ground, and that will change the preamp response of the 12AX7 and give you a little more of a brighter MIDI sound like you get with a Fender Princeton. You can take a look at their schematics and you'll see those caps. Let's give the 5F1 a final look over after the rebuild. Did quite a bit to it. Got our new filter caps installed. Now these first three caps are all tied together and those grounds go over here to the terminal strip. Whereas when you go over here, we have another ground. This is the preamp ground, and it feeds this volume pot. It also feeds the 1.5K resistor, and it gets its ground off of this audio input jack. Okay, so there is a separation of grounds, and you'll see that on MojoTone's diagram. Okay, we also rewired the 12AX7 socket, and I used color-coded wire. Also raised the board up about 1/4 inch with some standoffs and some rubber bumpers to give it a nice firm support, and it's nice and level. It's not sitting up on a nut like the original design was. So there she is, guys. It turned out great and it's pretty much noise free. I think that the owner is going to be extremely happy. Alright, so that's a wrap on the rebuild of the little Fender 5F1 amplifier. Yes, as you can see, it can get quite involved. If you miss something like a ground or one of the power supply jumpers, it can be a bear to troubleshoot because it's in that little tiny chassis, right? But remember, a lot of time and engineering went into the design of those amps. They've been out there for 50, 60 years and they're still running. So it's a great amp. You just have to take your time, study that diagram, and you'll be successful. So one other quick note before I sign off. Some of you have wrote in saying, hey, what's these old boat anchor meters that you've been using? Why don't you have like a nice shiny fluke? Well guys, I like these old vintage Beckmans. They got this cool rotary select switch. They're very accurate, very reliable. And they're vintage meters being used on vintage amp repairs, which D-Lab is in the business to do. Tell your friends to subscribe, pass the word. We'll see you again.